Ok, donc merci à tous d'être venus. Donc bienvenue à notre 10e Meetup Flutter Nantes. Donc ce soir, on remercie Seyos pour déjà pour le lieu, pour nous accueillir, et puis Zenica pour tout ce qui est matériel pour pouvoir mettre sur YouTube. Et donc, comme je disais, c'est notre 10e, donc on est content. Vous devriez applaudir. Voilà, merci. Et donc, merci à vous surtout d'être venus, de venir et même en live. C'est grâce à vous qu'on peut continuer. Et donc, n'hésitez pas à venir au prochain avec grand plaisir. Et voilà, du coup, je passe la main à Seyos pour leur petite présentation. Tu parles.
Ouais, ça marche. Enchanté tout le monde, merci d'être venu malgré ce temps qui n'est pas très très bien, on va dire, qui mouille un peu. Donc voilà, pour vous présenter un petit peu Seyos avant de commencer. En quelques mots et en grands chiffres, en fait, nous, Seyos, on est un cabinet de recrutement, donc spécialisé à 100% dans les métiers de l'informatique et du digital depuis maintenant 10 ans. On ne fait que ça. Donc uniquement pour des clients et pour des postes en CDI, des clients finaux, pardon, et pour des postes en CDI. On est opérationnel sur toute la France, avec des consultants qui sont régionalisés, et aujourd'hui, on est 45 collaborateurs. Des grands chiffres, donc aujourd'hui, Seyos, c'est plus, même aujourd'hui, on va être même plus à 400 entreprises accompagnées, et avec plus de 1500 recrutements depuis 2014. Et aujourd'hui, on a plus de 250 postes ouverts actuellement. Donc ça va être un petit peu les clients qu'on va accompagner. Donc il y a tout type d'entreprise. On va avoir des gros clients et des moins gros. On va des entreprises allant de la start-up, PME, TPE, au grand groupe. Voilà. Donc nos valeurs qui tournent autour de Seyos, en fait, ça va vraiment être l'expertise du marché, parce qu'aujourd'hui, on va avoir des consultants qui vont vraiment en fait comprendre le besoin du client et comprendre aussi quand ils sont face à un candidat qui recherche justement un poste, va vraiment comprendre en fait son besoin. On va aussi notamment avoir la connaissance du tissu local. Donc, comme je l'ai dit tout à l'heure, on a des consultants qui vont être régionalisés, et donc ça va leur permettre de faire notamment, pas seulement l'expertise de l'IT, mais aussi l'expertise de leur région, parce qu'aujourd'hui, chaque région est différente sur le marché du travail. Et on va avoir, pour finir aussi, un suivi personnalisé. Nous, on est très proche de nos clients, que j'ai envie de dire même nos partenaires. Et donc, voilà, on est très, très proche d'eux, et donc, pour justement les accompagner au mieux et qu'on comprenne au maximum leurs besoins et qu'on soit plus qualitatif dans la recherche. Voilà. Donc, n'hésitez pas à scanner ce QR code si vous voulez, voilà, pour voir nos offres qu'on a en ce moment pour tous nos clients dans toute la France. Voilà. Merci encore d'être venu, et puis bonne présentation à tout le monde.
Merci. Du coup, ce soir, donc, si je ne me trompe pas, il y aura Léa qui est à Dublin. Ok. Et donc, toi, Océane, qui est ici. Donc, merci à toi d'être venu, et à Léa d'être là aussi. Et puis, merci à Raouf qui est là. Il ne comprend pas ce qu'on dit, mais ce n'est pas grave. You understand? Ok. Donc, merci à vous trois. Et donc, on va commencer avec le talk de Léa et d'Océane. Donc, quand tu veux.
J'ai besoin de ça.
Parce
que j'ai le micro.
Ah, peut-être pas.
Ok. On m'entend bien à distance, c'est tout bon? Le micro, oui, oui, mais je veux juste vérifier que le son est ok. Do you hear me?
Yes.
Let's go.
Okay, amazing. Thank you everyone for being here, and welcome to our talk. Today we're going to talk about how to implement complex UI in Flutter. Before we get started, let us introduce ourselves.
Hi everyone, I'm Océane Gillard. I live in Nantes, France, and I'm a Flutter developer at Zenica. In my free time, I created a mobile app, which is named Score Barbu. The goal of this app, it's in Flutter, and the goal of this app is to be able to fill scores during a card game, which is a Barbu or Tafron.
And my name is Leah. I'm based in Dublin, in Ireland, and I'm a mobile developer at Yelp. During my free time, I develop a solution called Steezy. It's for handball statistics live during games. And our app is in Flutter as well. To start, I want to talk about why we're here today to talk about complex UI. So the first reason is in our work, we work with designers a lot, and it's very important to us to be able to have the tools to implement the designs that designers come with, and to be able to implement every quirk and detail, no matter how out of the box the idea might be or the implementation might be. The second, so we want tools that enable us to create those designs. And the second thing is we tend to call each other a lot to exchange ideas or get someone else's point of view about complex designs and how would you implement this and so on. And we thought if it interests us to have other people's opinion, like each other's point of view, it might interest other people as well. So we're here today to go through example and share our point of view with you.
So during this talk, we are going to see 4 use cases that we've taken from our application. The first one will be about stacking information and comes from the Barbu app. So to play a game, we need to create players. So for the Barbu app, we created a screen to create player. A player has a name, an avatar, and a color. And so we designed these cards where we wanted to fill the information of each player. What's complex about this design is that we want the avatar to overlap the container, and it doesn't exist by default with Flutter. So we try to see how we can implement that. So Leah, how would you do that?
I'd start by the beginning, creating a container, because that we can see that there's a rectangle here in our design. And then adding a little border radius so we can have a container that matches the design that was given. Adding a little bit of color as well. Now let's add the player name. So we know we want a text field. So inside our container, we can add it as a child. However, I can see that by default, my text field is aligned to the top of the container. So we can fix that by adding an alignment bottom center to the container. So the child aligns to the bottom center. Now let's try to see how we can add our avatar. So the first thing is we have a widget in Flutter that's called stack that enables us to stack things on top of each other. And so we're going to make use of that here because we can clearly see that things are stacked onto each other. I'm making use also of the circle avatar, which is by default in Flutter. So this widget enables us to have the little round avatar with the image inside and a background color. However, we can see that our avatar is not well stacked on our container. So let's try to see how we can fix that. So we can use position widgets to try and tell where each element should be positioned. So my thinking here was saying we can see the avatar is positioned higher than the container. So I was trying to position the avatar at the top of the stack and the container at the bottom of the stack. However, because I didn't constrain my stack, it's taking the full height of my screen, which is not what we want here. So let's constrain this. I hard-coded values for now just to see if my design matches what I had in mind. And it's looking a lot better. So now that I have one avatar, and instead of using hard constraints, like hard-coded constraints, sorry, I'm going to... Oh, I'm sorry. I skipped. Let me rephrase that. I forgot. I totally forgot about the close icon. So we do have our avatar and we have our text field and we have our container, but we're missing the close icon. So I'm using position again to position that and using an icon button. However, there's 2 problems I can see here. The first one is the icon is not centered with my button. And the second one is we can clearly see the outline of the container behind the button, and we don't want that. So to fix that, first of all, we can add a background to the icon button, and also by default, an icon button as paddings. And so if we remove this padding and set it to 0, then the icon is centered correctly. So now that what I was saying previously, we have one avatar. Now we know that we're going to have more than one player inside a game. So let's add a grid view to add multiple players. This enables us to, first of all, add multiple players, but also remove the hard-coded height and width constraints that I had set in my first example. So it's looking quite good. What do you think?
Yeah, I think it's great. But could you try this on a smaller screen just to check if it's responsive? Well, okay.
Too good.
Yeah, no. Let's see how we can fix that. First, we see that the container is really big on a small screen. So what we can do here is just adapt its size depending on the screen size and the size it can have. So we can use the layout builder for that. So the layout builder is a widget that allows the parent to pass its constraints to its child. And so now we can use it for the container and say that the container has 90% of its parent's height. Width. Sorry, it's a little small on the PC. Width and 60% of height. Now it's better. Let's try on a bigger screen to see how it looks. Well, now I think the avatar is a little small, so we can also use the layout builder to just increase its size depending on the constraints we have. And now it looks great on the big screen. Let's see how it looks on a smaller one.
It's looking great.
Oh, yeah, I think it's great. So we managed to create a page to create players. It's responsive and looks great like we wanted to. So what we learned here is how to stack information, first of all. So we can use the stack widget and position widget just to be able to move things like we want. There is also just a layout builder that can be used to make responsive design and adapt the design, the length, the width, and everything depending on the size we have.
So let's go and look at our second example, slightly different, around gradients mostly. So as part of suivi, we have all this statistics data from teams, and we wanted to enable them to share those stats on social media platforms. So we created this design of this visual to share those stats, like main stats. The challenges here, first of all, is that we want to create one code base that can adapt, one widget that can adapt to multiple formats, because we know publishing on Instagram is not the same format as publishing on Facebook and so on. And the second thing is we have those very specific colors. So just to clarify, we're going to focus on this widget specifically, so where we actually share the stats, not the whole visual. And here there's two things that are important and kind of tricky for us. The first thing is, so throughout the app, we have those two colors, the purple, the pink to represent the team, and the gray to represent the opposing team. And we want to reflect those colors inside the title here in a gradient that shifts in the center of the title. We also want the title to have this kind of like angled shape. And the last thing that we want is to highlight the best value out of the both values extracted. And so here the tricky thing is, so we want to highlight to go from blue to transparent behind the title. And sometimes the highlighted value can be on the left, sometimes it can be on the right. Sometimes we can highlight both values if they're equal, or highlight none if we don't have any values. So those are all the constraints. How would you go about implementing this?
Yeah, first, let's create the first line. So what we can do is use the row widget to just create each text next to each other. what we can do here is just add a little bit of padding, so we can use the main, the space around property to add spacing, the same space before, after, and between each child of our row, so that it looks better. Now let's see how we can create this background behind the text. So what we can do here first is wrap our text into a container and give it some decoration. So as Leah explained, the background is a gradient. So it starts with a red color on the center left of our container and ends with a gray color on the center right of the container. So we can just put a gradient, say that to the gradient, and Flutter and the painter of Flutter will just do its magic and create a smooth gradient so that it looks pretty right. So here we've got a background. What we can do is just add a little bit of padding around our text so that the background is not tight to the text size. We'll have more, it will be prettier like that with 6 pixels around each corner. Now let's see how we can create this strange shape that doesn't exist by default with Flutter, because it's by default the container is just a continuous rectangle. So what we can do here is use a clip path widget that has a clipper property. And so in this clipper property, there is a method that is get clip, I think. The slide will move to check. Yeah, that's it, get clip. So the get clip method can be used to create the path of our shape. So here we say that we start on the top left corner. We just move a little bit to the right, start tracing a line up to the top right corner. Then we move in an inclined way to join the bottom. We trace the bottom side, and then we close the path just by joining the first point we draw. And it looks pretty great. So we've got this inclined shape. What we can do is just add a little bit of padding again, because with this inclined shape, we've got the text that is cut, and we don't want that. So we can add a little bit more of padding on the horizontal axis. And now let's see how it looks if we add a second row, a second line on our screen. So what do you think?
I think we're up to a good start. It's looking good, but the problem that we have here is that the titles are not exactly the same number of characters. And so, well, first of all, the background is not exactly the same size, but also I feel like the shape isn't exactly the same as well. So let's try to see if we can fix that. So by looking at the design, I can see that the title is what takes up most of the space. So I'm going to go ahead and wrap those titles in an expanded widget. So because both of my rows are in the same widget, the same parent widget, and have the same width, the title will then take the same space. Now it's a bit on the edge. Now the data is a bit on the edge. So I'm going to go ahead and add a bit of padding on the sides of the data. And while we're at it, we can have a look on how to add the highlights of the values. The first thing I thought of is we want to highlight either the left or the right value. So let's add a background to the value itself. The problem then is that because we want this kind of smooth gradient with the title, the gradient would stop at the start of the shape of the title and wouldn't go to the edge of the shape. So I did a little trick instead where I actually changed the background color of the whole row and added the background color as a gradient, and we have the gradient goes from blue on the left side, goes to transparent in the center, so that's behind the title, and back to blue on the right side. And that way we have that smooth effect on both sides. Now we want to highlight only some parts of the gradients, right? So I added variables to highlight only the left, only the right, or both if we want. So it's kind of flexible. So let's say if we want to highlight only the left, then highlight left would be set to true, it would the gradient would go to blue, to transparent behind the title as usual. And then instead of going back to blue, if we set highlight right to false, it would just keep transparent. And so we have kind of this smooth effect that can easily be changed from one side to the other, or both if we want to. I think it's looking quite good, right?
Yeah, it's great.
So I think the main takeaways from this example is, first of all, try to work with the space that you have depending on the format that you have. And using widgets such as Expanded are a great tool once you understand what is the thing that needs to be highlighted in your design. And then also gradients can be very, very flexible and allow you to do a bunch of different things. Here we went up to 3 colors of gradients, but we can go so much higher and have so many different colors depending on the needs. And the last thing is the clip path, which makes it very useful when you have those odd shapes. The shapes we drew here is quite simple, but we can go a lot more complex if needed. So that gives a lot of flexibility.
So for our next example, we'll see how we can position points around the circle. So for the use case, so in the Barbu application, a Barbu card game can be really long. And so one of the main features of the application is to be able to save a game and resume it when we are ready. So it can be a few weeks, days, or whatever. So we need to resume the game. And when the game is resumed, the player needs to be placed in the same order than they were before. We all know that we will forget where we were sat when we started the game. So we decided to create a screen just to remember the player where they should sat. To do that, we created this design with a table represented by a circle, and where the player should be placed in the right order. We should display the name of the player and its avatar, and they should be equally spaced in the circle. So here I created this layout for 4 players, but of course it should work for 3 to 6 players because we don't have the same number of players on each game. So Leah, how would you do that?
This one's a tricky one. I don't exactly know how I'm going to do it, but I'm going to start by the beginning and we'll see. So first, I'm going to create my table. So the container, I can give it a shape of circles. So we have our table set. I'm going to give it a little padding on the edges so that it has space to breathe. Now I'm going to try and see how I can add my first avatar. So I'm going to bring back the stack because we can clearly see that the avatars are stacked on top of the table. So I think that's the most natural one to use. And I'm going to use the circle avatar again to show my little player. I'm going to try to position it. I'm going to hard code the position right now because I just want to know and see how it looks. So now that I have my avatar placed, I'm going to add its name underneath. And it's looking good for the first one, but I don't want to hard code every position. And I don't know how to go about it. Do you have an idea how we could do this?
Yeah, I made a little bit of research and I saw there is a math algorithm. Don't worry, I will explain everything. But there is a math algorithm to know how to place points around the circle. So for that, what you need to have is the number of points you want to draw.
So for us, it's the number of players, right?
Yeah, that's it. The radius of your circle.
So that's the size of our table.
Yeah, that's it. And now you're done. So if you want to place points around the circle and they need to be equally spaced, that means that you are going to cut your circle in equal slices. So each slice will have the same angle. This angle is called theta and can be calculated from the number of points you have. And then with some trigonometry, you can calculate the coordinates of each point around your circle. So let's see how it looks if we do that on the screen.
It's weird. We're missing a few circles.
Yeah. Well, that's really strange. Could you just draw the axis and highlight also the origin of your of the container, so the 0, 0 coordinates? Okay. Yeah. Okay, so the 0, 0 coordinates are on the top left of the container. I think that's because, yeah, that's the same thing on web and obviously, apparently in Flutter also. So for our algorithm, we need the origin of our calculus to be on the center of the circle. So we just need to move this origin, which is on the top left corner, to the center of our circle, and it should adapt correctly. So what we can do here is just add the circle radius to our calcul, and should look great.
It's weird because our points are not exactly on the circle. They're on the edge. Do you know why that is?
Yeah, I think that's the same problem than before, because when you position a widget, we position also its top left corner. So if we want the circle to be on the middle of the circle, we will need to subtract its radius so that it will be better. So let's see how it looks.
It's looking good. Let's try and see with our avatars.
Yeah, let's see how it looks. So what we can do here is just put the clip none behavior to our stack so that if the widget overflow the stack, they will always be displayed. So for the avatars that are on the edge, they will not be cut, and we will not have just half an avatar. And now let's try to implement our algorithm. So we've got data, we've got a list of players that we generate, we position all our widgets with that. Once again, it's a little bit strange, but I think we just position the top left corner of our widgets. If we just subtract again the radius of our avatars, it should be great. Okay, so this design seems to work. Yeah, it seems to work for 4 players. Could we try and see how it looks with, let's see, 6? Okay, and 3 of them, how it looks? Yeah,
nice.
I think that's pretty good. So yeah, we just created a table with players around it, and everyone is equally spaced. So what we learned here is how to position points around the circle, but I don't think you will have to use that often. But the main thing that we can gain from this example is that when you're trying to do something that's difficult, sometimes maths can help. And during your studies, the teachers always said algorithm and maths, it's really useful for development. Well, sometimes it's really true.
So let's go and have a look at our last example. So here we want to create a widget that can be reused at multiple places throughout the app. So here the use case is for web application. So that means that the screen size are going to be very different depending on the user. A computer, tablet, phones, everything can be used on everything. And I want this select to be used at multiple places with multiple different options. So we don't know in advance how many options we're going to have, what the size of the select, the width the select's going to have as well. And so we want to create something that's very flexible. And the idea here is that when we click on an option, this option will get highlighted by the square, the white square that we see. And when we change option, that would be the ideal, is to have a little animation when it goes from one option to the next. So that's the idea. How would you implement it, Ocean?
Well, let's try with the beginning first. Let's create just one option. So I think one option can be represented with a text button, with just a column with an icon and a text. If we want to have multiple buttons, and if we want them to be able to be in one line if they can fit, and just to create a second or a third line if they can't, we can use the wrap widget to do that. So it's adaptive, and it's depending on the size it has, the option will probably will move to the second or third, whatever line they have. So I think that's great. Let's be just a little bit crazy and do a little bit of refactoring by cleaning the code and creating the widget, which will be named select option to represent our text button so that it will be easier to understand after. So now what we want to do is to be able to know on which button we just clicked. So what we can do here is put our wrap into a stateful widget, add a selected button property, and just update it when we click on a button. So when we click on the first one, we will save the 0. If it's on the second one, etc., etc. So that we can know which button, first of all, which button is selected. Now what we can do is see how we can create our indicator. So these rectangles that will be on top of our buttons. So once again, we're using the stack widget. We are creating a container with white borders. With white borders and a little bit of radius. Now, what is really important if we want to be able to move our indicator and to have it always centered with a button above it is to fix the option size and to give the same size to our container and to the select options. So that when we try to move it, it will always be well displaced, because if the two values aren't the same, maybe there can be some disalignment in some sets. So here we created this this option size. We position the indicator on the first one with the first option, and let's see how we can move it. So what we can do is create just a method to calculate the position of our option. So because the option size is fixed, we know that if you click on the first option, it will be placed, the indicator will be placed on 0, 0 position. If it's on the second button, it will be on 0, 100 position, the third, 0, 200, etc., etc. So we can just create this method to calculate and dynamically adapt the position of the button. Let's see how it looks on the real screen.
That's looking great.
Yeah, I think it's working.
Oh, but it doesn't seem to map to the second row.
Yeah.
Let's see how we can fix that. So let's go back to our calculate position function. So here we can see in the first version that we were only calculating the position on the x-axis, so the column on which the option was placed. Let's try and see how we can calculate the column and the row of where our option is. So first of all, we get the index of the button that we just selected. We need to know the number of options that can fit in one row. This needs to be calculated every time because it very much depends on what the widget has in width. So in this example, I took the liberty of saying that the widget had the full width of the screen. It could be the parent size, like we've seen previously. So we calculate how many options we can fit in one row. Once we have that, we are able to calculate the row that the option that we just selected is on. So once we have the row, we need to calculate the column. And then once we have the row and the column, since we have a fixed option size, we're able to calculate where we need to position our rectangle. So once we have that, it's looking pretty good. It seems to be going to the second row. And the good thing here is that since nothing is hard-coded, if we have our example with 2 rows, but let's say if we had 4 rows, it should work the same way. The last thing that I see we're missing here is our little animation, right? The good thing is with Flutter, there's a lot of built-in animated widgets. We used a position widget to position our rectangle, our selects. and highlight the option selected. So instead of using a position, we can use an animated position widget. And this enables us to then set a duration of the animation and a curve. And by default, we have our little animation working, which is great. I think it's looking quite good and very flexible for all the different uses we might have of it. So to conclude, I think the two main takeaways here is that, first of all, there's a lot of widgets that come out of the box in Flutter that enables us to have dynamic, dynamic responsive layouts, such as the wrap widgets. And the second thing is there's a lot also of animated widgets that come out of the box that enable us to do some pretty cool stuff very easily. So definitely be on the lookout for those. And again, math to the rescue. With a easy math calculation, we can calculate the position of our options. So
during this talk, we saw 4 use cases. First, we saw how to stack information with the create player screen. We saw how to create dynamic gradients, positioning points around circles, and also creating responsive animated widgets. So those 4 examples were taken from our application, and they were examples that we really tackled on when we tried to do them. Of course, we could have discussed multiple other things, but we don't have time to do this tonight. But yeah, so I don't know what I'm saying. Sorry. So yeah, almost anything can be implementing. Yeah, if you just need to come back from this talk with one idea that almost anything can be implemented. It's really important when you create something to understand why you are creating this. So at the beginning of the talk, we said that we really want to work together with the designer to speak with them, to understand why they want the screen to look like this. And even if it's sometimes really hard to do this, we will just be able to adapt how we do that, sometimes make some compromise. But anything is possible if you just look a little bit and dig and make some research, ask your colleagues, your friends, the community, whatever. There is always something that can have another point of view and can help you with. For a little example, Leah presented the animated position at the end of the talk. I tried to do this and didn't work. I didn't manage, but it didn't work because I didn't fix the option size. And so when I tried to move my widgets, well, it was always there were a few pixels, but still a few pixels, and it wasn't great. So yeah, just by talking to each other and trying to share with you, with us, with everyone, it can help. So thank you for listening to our talk. These are our contacts and the QR codes to our apps if you want to see that. And if you've got some questions, just feel free. We will be happy to answer you.
Vous avez des questions?
Vous pouvez poser les questions au français aussi.
Moi, j'ai une question sur toutes les solutions que vous avez présentées. Vous avez rajouté les étapes de on passe une difficulté, on passe à une autre, etc. Comment vous avez ressenti le passage du non responsive de votre solution au responsive? Est-ce que vous en avez parlé à certains moments de OK, ça marche pour cet écran, on essaye sur un autre, ça marche pas. Est-ce que pour vous, ça a été la partie la plus dure de passer à c'est pas responsive à c'est responsive?
Je dirais pas toujours. En fait, ça dépend vraiment de l'écran et ce que tu souhaites faire. En fait, c'est un must d'avoir du responsive, mais c'est souvent le dernier truc qu'on check. Si on vérifie déjà que ça marche sur juste un écran. Et après, tu dis, bon, ok, je vais vérifier sur les autres cas, je vais adapter les petits trucs et et ça devrait le faire, mais enfin, il y a rarement des gros changements qui viennent avec le fait de faire responsive, je trouve.
Je disais ça aussi parce que sur la partie maths, ça joue beaucoup, ce qu'on doit vachement extrapoler. Je prends des exemples que j'ai où je suis sur une application, on doit afficher certaines fois 2 contenus par colonne, des fois 4, des fois 6, etc. Et du coup, on a des espèces de tuiles un peu comme vous, votre option. Et il faut à chaque fois qu'on soit capable pour chaque device de calculer combien on rentre de tuiles, combien on met enfin, quelle taille on leur donne, etc. Et quand on commence à rajouter du calcul de position, etc., le côté extrapoler la donnée de, par exemple, où vous positionnez votre ouais, exactement, ou même à la fin, là, je voyais avec votre wrap, on a, ouais, enfin, sur un téléphone, on va peut-être en rentrer 2. Je sais pas si vous avez tout le temps fixé la taille de l'option ou si vous avez rendu ça un peu plus dynamique, genre, bah, je veux en rentrer 4 ou des fois, je veux en rentrer 6. Je sais pas comment vous avez fait, mais cette partie-là, elle est vraiment, elle peut être vraiment tendue, même une fois qu'on a trouvé la solution au final.
Ouais.
Et je peux répondre à cette question. Donc pour le select, par exemple, on a décidé pour la présentation de donner une valeur en dur. Mais dans la réalité, en fait, on calcule à la création du widget en fonction des tailles de l'écran ou des tailles du parent, quelle taille d'option on veut, en fait. Donc ça, ce qui est intéressant dans cet exemple, c'est que concrètement, là, on l'a mis en dur, mais si on veut que ce soit beaucoup plus dynamique, il y a juste cet élément qu'on doit changer, en fait, et le reste va s'aligner derrière. Parce qu'il y a qu'un seul élément, en fait, qui est hard-codé dans notre exemple, c'est celui-là. Et il y a toujours... c'est toujours difficile, je suis totalement d'accord avec ce que vous dites, c'est très difficile de voir entre quand est-ce que je dois utiliser des maths et je dois calculer tout, ou quand est-ce que je dois utiliser les widgets Flutter, comme les expanded, les choses comme ça, qui vont faire un certain niveau de responsive par eux-mêmes, et avoir cet équilibre, c'est assez compliqué.
Je suis bien d'accord.
Merci.
Il n'y a pas de questions. Non. Ok, merci.
Je le partage juste.
Merci. Juste rapidement, je ne sais pas si vous avez vu cette semaine, il y a eu un petit partage de quelques nouveautés pour la prochaine version de Flutter en général. Du coup, je vous ai mis un petit QR code si vous voulez accéder à un article Medium qui reparle des nouveautés qu'il va y avoir dans la version 3.19 et dans la nouvelle version de Dart. Et ensuite, juste rapidement, un petit agenda des prochaines conférences qu'il peut y avoir, que ce soit autour de Flutter ou autour du mobile, parce qu'on va parler de mobilé pour Nantes. Mais demain, il y a Flutter Hero à Turin. Je l'ai mis là parce qu'en fait, il y a toujours des billets online qui sont disponibles. Donc en fait, je ne sais plus le prix, mais vous pouvez quand même y accéder pendant toute la journée à tous les stages qui sont en ligne. Vous pouvez les voir. Le 24 avril, à Paris, il y aura la Flutter Connexion. Donc ça, vous avez encore le temps de prendre vos billets. Et par contre, les CFP sont terminés. Il y a Mobilis Immobilier le 18 juin à Nantes. La FlutterCon de Paris, je crois que vous pouvez prendre vos billets et les CFP, ils sont ouverts. Et qu'est-ce que j'ai oublié? Ah oui, Mobilis Immobilier, le CFP, il est ouvert jusqu'au 1er avril. Donc voilà, n'hésitez pas. Et pour Flutter & Friends qui est à Stockholm, il y a des billets en vente, je crois, jusqu'à ce soir, ou si vous en achetez un, vous en avez un deuxième d'offert. Et sinon, les CFP, je ne sais pas si c'est déjà ouvert. Mais voilà, ça vous donne une petite idée de ce qui se passe en Europe pour les mois, ouais, un petit peu plus que ça, même si c'est septembre, et les quelques mois à venir. Vous avez des questions là-dessus? Non.
L'événement numéro 6.
Bah, en fait, j'ai hésité à l'enlever. Je me suis dit, ouais, il y aura peut-être un qui va se rajouter ou pas. Je l'ai laissé. C'est un secret. Ok, bah, du coup, on va passer à Raouf maintenant. Donc, si tu es prêt. il vient de loin, il a failli pas arriver avec son avion, donc vous pouvez l'encourager. Donc, tu as des branchés pour le brancher. Celui-là. Et par contre, est-ce que je peux laisser l'ordi? Je vais mettre le sien.
Is it live? Is it okay? All right, sounds cool. Okay, hello everyone, good evening, bonsoir. Okay, that's as far as I can get. So my talk is about unlocking new potentials in Flutter with shaders. If someone told me this or gave me this title probably 3 or 4 years ago, I will be very skeptical, because one thing Flutter promised me from the beginning was you never say no to your designer. Whatever your designers give you, you will be able to do it. And that was like got us in kind of troubles, but we had to go with it for a couple of years while we are learning Flutter. But then some things happened and they changed my mind. Obviously, the type of designers I was working with changed, and also the type of designs and the type of clients I had to work with also changed. So I had to unlock some new potentials, and that's what I will hopefully try to share with you today. And we'll be able to see a couple of really cool demos, some of them made just for the event, so that they can be exclusive. So chapter 0. So we have to go back to see the limits, and I have to take you back on a little story or a journey before. I'm pretty sure most of you probably have seen this in the Flutter documentation. This is a bit bigger. It's a comparison between what happens when you are scrolling your application between Android and iOS. So on the left, we have Android, and the right, we have iOS. And you can easily tell which one is more beautiful. Like the iOS one seems to be as of today, but the Android one seems like definitely in the 90s. So I didn't like that for a very long time. I was wondering, why is it like that? Why they never changed it? But then Android 12 came in. Sorry, this is all in Chinese, so that you don't focus on the language. You just focus on what's happening there. They changed actually how it's happening on Android. I think it was 12. Yes, so on Android 12 now we finally have something that looks as good or even better than the iOS one. I saw this, I was super excited. I went to the Flutter repo, I created this issue, and it's probably now one of the most commented ones, or like thumbs up based on the Flutter team, because that's how they prioritize what they work on. But yeah, it was probably on the same day. I didn't even finish. I saw this in the announcement, I created the issue, and I felt I'm clever enough to suggest a solution. So I told them to go ahead and use some widgets, and they felt like, yes, I can do this. I can just add a little bit of spacing when you scroll at the end, decide how much spacing to add. Using a transform widget, I'm going to scale on the y-axis, and we'll end up with the same effect. Obviously, that's not the case and will never be the case. If we take a closer look at what's happening here, you will not see it from the first time. You'll probably need to take a couple of screenshots and compare them one next to the other. But what's happening here is not just a uniform transition where everything is scaling down and a little bit more spacing is added. You can see the text is getting larger on the y-axis. The icons are getting larger on the y-axis. But more importantly, it's happening on a larger amount. Like if the value of the transition is, let's say, 5 to 9 at the top, it's less at the bottom. So it's non-uniform. So it will take a couple of minutes to notice that, but the question is, how are we going to be able to achieve that with a widget like transform widget in Flutter? It's uniform, and whatever values you provide to it is going to apply to the entire thing. And that's when I was introduced to shaders. This is just to showcase what the Flutter team ended up doing right now, something very similar. This is the current implementation. If you use the latest version of Flutter, this is the current implementation. It looks very similar. They tried to mimic it, but the issue itself hasn't been closed because they still didn't get 100% match with what the Android team has. That's why I was introduced to the notion of to the notion of shaders or fragment shaders in general. It was mentioned by the Flutter team that that's what is needed in order to get that effect to work reliably. But then once you see something, you always ask what other places this actually exists in. So here we'll take a few other looks at some examples. For example, here, this is a blur. You could say that this is called the lens blur. There are multiple types of blur as we will see in a bit. But what we are looking here is something that will not be able to achieve with Flutter easily. Like we cannot just say use the blur widget, backdrop widget, or whatever other widgets that are provided by Flutter in the blur. We will not be able to achieve something like this because it's more custom than that. Here are some other examples. For example, here, the first one is called Books Blur. It's literally the cheapest blur ever, and it's just like you go through and you make it look something blurry, but it doesn't actually change a lot from. It doesn't make it beautiful. It just makes it blurry. We have the radial one. We have the tilt shift. This is a very common blur where you want to make stuff in the middle look smaller, and you probably have seen it in the Sherlock Holmes TV show. They make use of that effect a lot to make the taxis look a lot smaller. We have here the shape blur. We have another one called, I think, the old blur. I mean, at this point, I forgot. All of them are almost the same. It's just blurry. Yes, more blur. I think this one is the surface blur. The other one is the lens. And finally, we have the Gaussian blur. The Gaussian blur is actually what is used in Flutter. So this is what you can achieve with Flutter. If you use the image blur widget in Flutter, this is what you can use. Obviously, you can say it has multiple parameters, so we can use it to do anything. And these are the whole parameters that are provided by that widget. These are like the blur, is it going to be on the x-axis or the y-axis? And you can play with that, and you can see how much the blur is affected. We also have the tile mode. The tile mode is, you can find it in other widgets, not just the blur, but it's a good chance to understand the difference and what to make use of it. So for the blur, because it has to go through every pixel on the screen and tries to apply the effect on that blur, imagine we are at the edge. So we are at the edge here, and there is nothing on the side. So what color are we gonna look at to decide what will be the color of the final pixel? And that is literally why it's called an edge case, because it's at the edge and we don't know what's beyond that edge. So we have multiple tile modes. We have mirror, for example. Mirror is gonna say, look at the last pixel on that position and mirror it, and do the same for the other one. Mirror is almost the same as repeated. Repeated is just going to duplicate the same pixels. It's not going to mirror them from the origin, but it's actually going to go through from the beginning to the end, and it will replicate it just on the left or on the right or whatever we are asking it for. Clamp, you will see that there are voids in multiple places. Those voids are coming because there is nothing that they can take colors from, so it ends up like that. We have decal, which is like clamp, but it is more transparent. It doesn't have the black holes, but it has transparent ones. Like if we remove the background, it will be transparent. So that's the difference. But why I'm showing you all of this is because all of what we have seen is whatever Flutter provides. There is nothing else that Flutter provides more than that in order to create blurs. And the question is, how are we going to be able to implement all of those blurs? We have seen probably just 9. Like there are other, not hundreds, but there are actually a lot other blurs. And if your application is image processing heavy or needs to have like something very visually, aesthetically pleasing or very custom, you cannot do it with a blur. So that is also another thing where even with we can do everything with Flutter, we will not be able to do it. But now we go to some other simple examples. Like I'm going to go through these very easily. So for example, here, this button. Like, what's the starting point? Like, how are you going to implement this? What's the starting point? Like, well, what are we going to do? These are some effects. For example, the water ripple effect. We'll say start with a let's start with a custom painter, but yeah, we'll be a custom painter for a while before we figure out how to simulate it in a way that it is as smooth and as real or imitating the real water effect as possible. This is another example. All of these examples, they seem to be random, but we will see in a practice and how actually they turn out to be great for visual effects in real applications. Like this one here, no one uses this effect. This is 2008. No one uses this effect in your application in today. But we will see some real examples where it can make it look even better. So this, obviously, yeah, this is just wave distortion. We can do something like this with a custom painter. The reason I'm putting it here is the same for the zoom blur and for the noise and all of these. It's not because they are not possible to do with a custom painter. It's because even if you do them with a custom painter, the application is going to scream for help because it will be drawing a lot, and it will be drawing a lot every single time the screen has been refreshed. So we will see a lot of junk in the application. It's not because of the whether it's possible or not. It's whether it's possible or not based on the on the refresh rate that's possible by the device. This is another example. I'm going to pause here because it has some real nice examples by two people in the Flutter community. One is called Creative or Maybe Not. He created a whole case study around this meatball effect and how to achieve it. He actually did it literally with a custom painter, but at the end, he wasn't able to achieve the smoothness of whatever is available with shaders. So he goes into the point to validate that we actually need shaders to achieve something as fast as this. Same use case by Super Declarative in his channel Processing, where he discusses this exact same problem. Now we go to chapter 1. We understand if somehow something is done, then we can understand how we optimize it. So let's take a look. This is an image. This is a blurred image. What happens in between is definitely not magic. It's something that I can definitely tell was the question you asked in the previous session. It was about math, right? It was about math. Yes, I know it was about math. I heard that word. So it's not magic. It's actually just math, and we'll show how that works. I created this very simple demo application which explains how the blur effect works step by step. So if I go here to this interactive example, so here I'm simplifying it. These random colors are just, you can imagine them as a picture, but they are not. Every picture is just a random set of colors. So let's simplify that and look at it this way. And we want a blurred version of that. So what happens in between is something very simple. You go into the color, and then you go to create a kernel. This is 3 by 3. It can be bigger to look at the pixels around it, and then try to smooth them out. So if it looks at all the pixels here, you will see the a value here, which is just like a kernel value that will calculate based on the color of each one of these, and then try to put an average. That average is going to be the result of the final color. So here, if I click here, I guess it was double click. I forgot what they mean here, but yeah, whatever was that, I think, yeah, it's double click. So every time I click on it, this is the result. The final result is there. Is definitely a different color, but it is the color that combines the colors around it and averages them and gives you the final color. That's what we call a blurred version of it. So here, if I try to do it to all the values here, it will end up with the blurred version. We are not using the most optimal blurring function, and we are not using obviously a good picture to show what the final version looks like, but it's not too far away from it. But at the same time, we can definitely see that it is lighter and it is a bit different. So as I said, if this is just logic and it is just math, then what would be the problem? Why we wouldn't just go ahead and go to a custom painter, take a look at the picture, read the pixels around it, and then decide to create the new picture. The problem here is that when you use a custom painter, that code is dark code. The code is going to be running on the CPU. We take a simple example, an image that is 1,000 by 1,000 pixels, and then we try to apply the blur effect. I mean, it's very applicable. Everyone can just go ahead and try to do it, and you will see that your application is no longer going to be responsive, because the CPU has to process now 1 million pixels, and that 1 million pixels is like the minimum. Like if you have a very small image, all the images that we are seeing these days is like way like 5 times more than that. So if we're doing at least 10 operations, as you have seen, we take a look at the colors. So if we take a look at the neighboring color here, and neighboring color here, neighboring color here, each one of these operations. So if we do 10 operations here and there, we simply have 10 million operations that's happening just in order to blur one simple image, and that is not acceptable. That's why we will be introduced to the GPU, which I'm pretty sure all of you know that it is the graphical processing unit. I always get this joke that but nobody gets it. But it's for example, here with the CPU, what do we have is that what we are doing is the operations. It will be sequential. Every time we are trying to look at the pixel, we will have to look at this, and then the next one, and then the next one. It will be one operation after the other, one operation after the other. It's obviously super fast. We can do a lot of that, but the problem is it will not be as fast as doing all of them at the same time. And that is where the GPU is actually made for. It's literally made to do this. It's made to do operations that are highly parallel. We can obviously go back to the CPU where we can use threads, isolates, in Dart, and all of that, but that's not going to take us any point that is nearby the GPU, because the GPU is doing it by the hardware. It's not doing it with the software. There is no limit on the amount of threads that you can spin, because the GPU, what we will be seeing is that for every pixel that we have, there will be a thread that will be running your code for that specific pixel. So obviously, as we know, with Dart and the CPU, even with other languages that are not Dart, but are highly parallel like Rust or C++, will not be able to achieve something as fast as the GPU. So how do we access the GPU in Flutter? That's called shaders. Shaders is the notion of a program that runs on the GPU. So when I say shader, it's just a function, but it runs on the GPU instead of running on the CPU. There are multiple types of shaders, but fragment shaders or pixel shaders are literally just the last type of shaders where you can actually write some logic and end up with a result around it. So with the newest versions of Flutter, I think this was just by 2 years from now. It wasn't very recent, but now we can have access to fragment shaders. We cannot access any of the others, but this one is the last step, and it is the fastest to go through. Flutter already uses shaders. For example, we have seen in the previous session about gradients. Gradients are literally shaders. We have seen blurs in this session. We know what blurs are by now. They are also shaders. So if we want to take a look, for example, at a simple case study here, the image filter, you will use it if you want to use blur effect in any, like whatever. Is it backdrop filter? Is it a box shadow? Whichever kind of blur you want to apply in your Flutter application, you will have to go through this image filter API. And if we dig deep, because Flutter is open source, not like Apple, we can take a look and see what's actually happening behind the scenes. What's happening behind the scenes is creating something called Gaussian blur. As we mentioned by now, Gaussian blur is just like using the Gaussian function that is supernatural and like has a bell curve that looks more natural to the eye than any other blur. That's why it's the most popular, and it's also somehow cheap, but not the cheapest. So we take a look at it. Now we are in the engine side. We left the Flutter framework. We are at the engine side. We're looking at some code, a little bit more, and finally we arrive at this point here where we have an entities in Impeller, and all of them are kind of shaders. And we can see, take a look at the first shader that's used here, which is the Gaussian blur. If we take another deep dive, we will find other types of blur. For example, they try to optimize when the blur is not needed to be fully Gaussian, or the blur is not needed to be fully looking at all the pixels. They can try to use different paths to make it a little bit more faster, but all of them in the end are going to rely on the Gaussian blur function. So what we are seeing here is a file that ends with GLSL. which is the language that is used to write fragment shaders. There are other languages, for example, in the Apple world, it's called Metal. In Windows, it's DirectX or whatever. Like, there are so many of these languages, but let's just call them fragment shaders for now. And here is one other sample. For example, if you use the latest version of Flutter and you deploy your application to Android 12 and more, if you take a closer look, it's no longer just the window ripple effect that is a circle that gets bigger. If you actually zoom, or I don't know, maybe you have good eyes, it's not like me, you don't need to zoom, you actually can see it easily. It's sand that randomly drops behind the scenes, and that sand is randomly generated to look a bit more color, because randomness is beauty. So that's why it looks way more beautiful than a normal sparkle effect that is a circle that gets bigger. So this, we can go to the Flutter framework, and we actually find that they are used in the Flutter framework, not even in the engine. You can take a look. It ends with fragment shader. It can be with GLSL, but that's just the extension of the file. And now a question is, we have seen that all of the cool stuff is coming from fragment shaders. We have seen that by customizing them, we will be able to achieve some great stuff. Now let's go to do some practicalities and show you a little bit of code. I don't think I will be able to do live coding today, so I'm just going to show you the simplest code ever, and I will walk you through it. Yeah, had an early morning flight, and you know all the weather here this morning, right? They had to go like literally in the airport. They were scaring us. The pilot was saying, we're gonna go back now. We're gonna go back now because they will not allow us to land. Like, yeah, that's gonna be a long day anyway. So we have a very simple shaders application. This one is literally just the simplest shader we can ever have. You go here to create a new folder called shaders, and whatever you put there, just put .frag in it. And that .frag is an extension for to say that this is a fragment shader. This is the simplest we can ever have. It's a main function that looks like C++ code, but the only difference is that it has a frag color that we are setting the values for it here. I'm assuming you all know that these are just the RGB colors, and this is the alpha color. So what color is this actually? Is it red, blue, RGB? So it's, yeah, so this has to be green, right? Okay, yeah. Let's see. Okay, yes, it's green. Wow. Yeah. So if this was confusing, taking a look at the other codes is definitely going to be more confusing. But the only thing I'm going to show you here is that this is the simplest fragment shader we can ever have. It's a main function. The input for the function is going to be some values that we'll provide from the Flutter side, but the output, there is only one output. There is nothing else you can do in the logic here. You cannot use like multiple, like you can use some logical operators like if, for, and all of that, but it's very limited. That's why it's a different language. They do not support like literally C++. It's very limited. You do not have access to the C++ standard library. You have very, very limited things that you can do, but what you have to know is that all what you are able to do here is going to be done super fast because it's done on the hardware and it's done per pixel all at the same time. So here we are rendering a color that is green. The setup is we write this file, we go to pubspec.yaml. We have, instead of, well, we have assets, but we have additionally shaders where we say all the shaders that we want to include in our application because they will need to be compiled before the app starts actually. And then the way we use them is we load them using this new API called fragment program. We say, it's coming from this file, then get me the fragment shader. It's asynchronous, it doesn't load synchronously, so that's why I'm doing async await here at the beginning. But then the good part is how do we use it? It's literally still using a custom painter, so we have to go back to thank the custom painter. Even though we say bad things about it, we still have to go back to it. The only difference here is that it's being hooked. It's not, we are not actually running the logic on it. We're not running any dark code here. It's just delegating that logic to be running on the GPU at that point. But that's a very simple shader, and we'll be seeing more fun stuff in a bit. But that will be the first simple shader. It gets a little bit more very easily, but what I'm showing you here is that the uniforms is the way to pass values from the Flutter side. So here I'm passing the color instead of just hard coding the color that will be the output. I'm just passing it, and in the Flutter side I'm passing it as RGB values divided by 255 because that's what they are expecting it to be. There is probably a better API to do that, but we are showing you the raw API here to explain how it works. Now, to demos, we have a few demos for you. So all of these demos are demos I have been working on since 2022. So literally for 2 years, I've been just doing 2 demos. I think I promised myself one thing, which is to not learn how to write GLSL, but by now it's just by default. I know probably 2% of it, but I'm still not able to understand that language fully. So all of these examples here, I'm putting the code. All of you can take a look at how they are made, but I will provide the QR code at the end as well. So this is a button using the same method that we have seen, for example, the sparkle. This is the button that does a really nice hover effect. For example, you want to make people, I mean, I don't know if people are actually going to click on this button. They will be just hovering and hovering by. It's not very useful UX friendly, but it's very nice in the UI. But it shows an example of how we can implement that on a button. The other one is the blurs. So all the blurs that they have shown you are obviously were implemented in Flutter. Otherwise, I wouldn't have shown them to you. So I have this simple application here where all the types of blurs that we have implemented, and we can hopefully scroll between them, I guess. Yeah, scroll between them and see how they are implemented. Make sure that they are actually running fast as well, and compare them at the end by the Gaussian blur that is provided by Flutter. So all of these were like, you can take a look at the code of how you can actually use them in your application if you need one of those really custom blurs and you want to use them. Another one is very famous, at least in the latest version of iOS 17. If you look closely when you are scrolling at the edge of the home screen on your iPhone, you will see that the blur effect is no longer just strictly a shape that is completely trimmed. Like, you cannot tell whether you are in the blur side or you are not in the blur side. So it's called the faded blur. It's a very common design now in the iOS world, and obviously we can do it in Flutter. The reason I'm bringing it here because I want you to remember if it gives you back any memories from any of the other blurs, because it's definitely not made completely from scratch. The blur is actually the one that we have seen here. That is called tilt shift. So tilt shift happens from the top to the bottom, but we have control. That's why we are doing the custom fragment shaders in the beginning, is because we want to be able to control them. So we have the tilt effect. We just apply it at the top because we can say a simple if condition to say if the pixels are above this limit, then just don't apply the effect. As simple as that. So it's based off of it. And now we have another one. This one was just a random one that was asked by someone. Asked me how to do this. This is Instagram. So Instagram, when you click on a picture or a profile picture, they have a background that is blurred. But if you see in the details, it's not just blurred, it's blurred and pixelated at the same time. So called it pixelated blur, and you can take a look at the sample over there. This was actually just a challenge from someone saying that like the Android, they were comparing Android weather application with the iOS weather application, and they were saying that, come on, look at this. Why there are no designers in Android? Why does it look so bad? So I tried to actually get literally the same. It's going to take me a couple of years to get the same weather application that they have, because it gives a lot of work into it. But this one was a very simple one where we just show that you can tell what's the fragment shader here. It is the snow in the background. And it's running very smoothly here on an. This is on an iOS, but they recorded this on Android just to make sure that they also know. This one is the one I made for the event. It's called the Mac Genie page transition. I have the code here very lightly. It's not very. It's not. It's really just for learning practices, but you can see how cool the effect is when you're probably trying it on your device, because. I don't know how to explain it, but once you feel it, it feels like you really are squishing something, because that was the only satisfying thing about it. Obviously, on the video, it looks like super weird, kind of, but when you're trying to play with it, it feels like a little bit more physical. So that's why I was probably clicking on it a lot. This is another one called blurry up bar. So you know how we have the effect where we blur the up bar at the bottom, and then that blur is always looking the same. So I try to use the blurs that we have seen from other types of blur, for example, the glass blur. But the reason I did this experiment at the beginning, you will see it in the README, is the reason blur effect makes your app janky is because it's applied with very big values. So you say like apply it with 10 sigmas, 20 sigmas, and then you suddenly say 50 sigma. 50 sigma is going to literally kill the scrolling of your application. But the answer to that problem is, what if there is another blur effect that looks blurry, but we can achieve something that looks nice? Because we have to differently, like the Gaussian blur looks simple, but the reason we do it is because the reason we use a blur effect in the beginning is to make something beautiful and hide information. So if we can achieve that with something else, I mean, this is blurry. I mean, obviously, to me, it's blurry. So if I can achieve it with 10x cheaper on the GPU, then I will definitely do that. So that was the whole test here about blurry up bars. You can see in the README some documentation about use cases where this will be helpful. We have the 8th demo. This is a name drop for iOS. So if you put two iOS devices and you put them next to each other, and then it blows up, right? So that's an iOS thing. And with Flutter, we have access to Android and iOS. I made this on Twitter, and it blew up literally just because people liked it. But this is when it doesn't look cool, because it's by itself. But if you have two devices next to each other, it will just look cooler. And obviously, it doesn't share any data. It's just the animation. But it's made fully with shaders. The reason this is possible is because we have the blur. We have something I shown you at the beginning. Remember, water drop. This is where it's coming from. It's not like a random effect. It's like a water drop that's happening at the anchor, at the top center of that place there. And then we combine it with the blur with a little bit more math. We can actually finally end up to that one. This is the final one. I think we can show this one live because I have already published it live, and we can see it. So this is how it looks like. It's like very satisfying effect, and it looks like paper is being flipped. But on a modern application, this doesn't look like 2008. I mean, I don't know if you agree with me or not, but it definitely does not look like 2008. It looks a bit more modern. The code for that one is also available on a different repo. But those are the samples. Now, practically speaking, I just want to make sure a couple of things. The reason all of this is possible is because something recent in Flutter called GPU images. A GPU image, we used to do quite a lot of hacks in order, for example, if you want to take a screenshot of a widget, like you say you have a button and you want to transform that one to a PNG and send it. Or you have a view, a list view, and you want to transform that into a PNG and you want to use it. We had to use quite a lot of context, global key, asynchronous stuff to do that, so it wasn't very cheap to do, and it was hacky. But recently they have added something called GPU images, which is taking the images straight from the rasterizer that's happening literally at the last step of rendering in Flutter. They take that and give it to you synchronously. So whenever we apply that effect, we can apply it to the whole widget, to the whole application. For example, the iOS name drop, we just take the whole application and we draw the effect on it. It's not like the effect is happening on this widget or that widget. It's taking the whole thing and transforming it into an image. The reason it's possible is because it's coming from the GPU synchronously. There is a widget in Flutter. Not sure how many of you have heard of a widget called snapshot widget. I haven't heard of it until I started researching this. It's like a widget that literally just transforms your widget, or whatever is inside your widget sheet, can be your entire application, into a GPU image that you can apply these effects on. So a GPU image, let's take that name out of it, UI.image. So you can take a UI.image and you can play with it in a custom painter as much as you want. Snapshot widget is going to provide you with that. And one more thing, We mentioned image. Image has a memory load, so it can be very expensive if you're doing that. So that's one of the things I mentioned on the scrolling example. If you're doing it with scrolling, you're actually literally creating a lot of objects, and then the garbage collector is removing them at the same time. So it's going to be really expensive on the memory, and you might be kicked out by either Apple or Google at some point, because that will be using a lot of memory. So that's why it should be used only for short-lived animations. It's not me who was saying that, it's the Flutter team, because they also use it. They use this effect on the zoom blur when they transition from one page to the other. They actually use that. So what can I use fragment shaders for? Some advanced visual effects. Some effects that are actually working, but we want to optimize them. Customization and control, because we literally have access to every single pixel on the screen. What other customization we can go over? And the more practical one is really real-time image processing. If your application is going to be targeting any of these use cases, it will definitely get some help from fragment shaders. Things you can take a look at. The very first thing is writing using fragment shaders. It's a document by Flutter team. The book of shaders is the only probably resource that you will be able to learn what kind of magic is being written in GLSL or Metal or any of those. It's basically in the basics, the most basic form, linear algebra, or on gas, whatever. Yeah, it's just that. And then we have Shader Tool, where you can find all the inspiration and the demos. Obviously, after you get all of that done, you will probably need some optimization on those shaders, because even though they are fast and they run on the GPU, you still can write terrible code that will actually make the application junk. So we will need to know how to make something efficient. The code for all of this is here, and that's it. If you have any questions, please let me know.
Vous avez des questions en anglais ou en français et quelqu'un traduit, pas moi.
Does it work on all Android phone?
Yes, it works on Android, yeah.
Without GPU?
No, it needs a GPU. Yeah, 100%, you need a GPU. And I think there is a limit on, but whatever is supported by Flutter is supported by fragment shaders. That's the reason why they have a limit on the version that can be used. For example, there is an older version of GLSL that works on some really old machines, but Flutter doesn't even support those targets. So
Okay.
you can hack around it, but definitely not.
Hi. So a question I had is you mentioned some kind of shaders. There are many kinds of shaders. You mentioned fragment. You also mentioned vertex, the selection, this kind of shaders. And I always have been wondering how do we have any kind of way in Flutter to code fragment shader, or do we have only the end on the last step, the fragment one?
Well, that code that it was showing here, I mean, it didn't show the code because I knew that was going to go over time. But for example, here the MacGenie effect. If we take a look at the code here, this is the code that we are writing. We are controlling here at the GPU level. So this is the only way in Flutter that we are natively able to communicate with the GPU. We cannot write vertex shaders, are you saying? There are plugins where you can go through the native view and then use OpenGL to go through it, but at the expense of what? Because at the end of the day, if it has to go through all of those steps, you're not all the gains that you're gonna get from the speed of the GPU, you're gonna lose by going through all of those layers. So yeah, this is probably the fastest way we can access like fragment shaders in Flutter, but yeah, there are hacks where you can use, if you go to pub, you go search OpenGL, you will find a lot of plugins where you can actually just write other types of shaders. But yeah, it has to go through
yes, by bypassing the Flutter rendering pipeline and going through the native one.
That
Okay.
is definitely going to be an expensive operation, and you're going to lose whatever you're winning here.
Okay, thank you very much.
Personne d'autre? Si.
Hello. Are there other use cases aside from like short video visual effects that you've shown to use shaders? I was thinking maybe like video games, but I believe maybe it's like too much work for video games.
There's a game called Tori. It's by a guy named Runan. He's also like does a lot of shaders stuff in Flutter. He made literally a game in Flutter that is based off like shaders. So he like also one of the main open source contributors to Flame. It's the game engine for Flutter.
Yeah.
So he made this as a demo to showcase the power of shaders with the Flame and in-game and in general. But it's a very I mean, I can show it right now. Hopefully, yeah, I have it here. And why don't they don't have a video? I don't know. Anyway, this is the game.
Maybe on YouTube. Maybe on YouTube. Sorry, maybe on YouTube.
It's definitely open source. You can take a look at it here. It's like called Tori. So it's a game based off fragment shaders. That's a very good use case. But going back to your question, there are any other use cases? As we have seen, like for example, custom blurs is a use case. Short-lived animations is definitely a use case because otherwise you cannot do more of it. I have been working on a different demo recently, which is shadows. So shadows, you can obviously do shadows for, if you have a container, you can do a shadow. If you have text, you can do a shadow. So let's say you have a transparent image. How are you going to do a shadow for that? You can do it with a backdrop filter, and then you draw the image 2 times, and then you try to recolor it with a color filter widget. But then let's say you want to make the shadow looks long, like the shadow is coming from this side or that side, and it's like the sun is getting away, or the source of light is getting away. How are you going to make that like a long shadow? It's very specific. Like you have to make it very continuous and it goes there at the end. It's not like just a duplicate of the widget and going back here transforming it. So that's another use case, like shadows, real-time mirroring effects. Like for example, the mirror widget. Obviously, all the gradients that are in Flutter are already like shaders. It's just like Flutter makes a lot of customizability. That's why we don't need to actually make custom shaders around them. But you can. The world of gradients is fully like
full of shaders.
Yes, full of options. So they have other types of gradients, mesh gradients, for example. You cannot do mesh gradients as simple as that in Flutter. Like we can do a gradient that starts from here and starts from here and ends here. A simple one with a couple of steps, or we can do one that is radial or a sweep one. But we cannot do one where, let's say, the color starts here and then there is another color here, and there are like multiple sources of colors, and then they integrate with each other. That's a custom shader. And Renan has a good one, like has a sample on how to make a mesh shader with these. But yeah, the possibilities are obviously a lot. But the good question is more use cases. That's what I have been trying to figure out. Yeah.
Thank you.
Oh yeah, he found the video, but I cannot play it here. It's a very small one. Yeah.
Thank you.
Personne d'autre? Non? Ok. Merci.
Thank you.
Thank you. Du coup, c'est fini. Merci à vous. Parce que vraiment, c'est un jeu où c'est juste une bête qui monte et dans des trucs fondus et elle monte en c'est un